The practice midterm, practice final from last quarter, including the programming problems that were due yesterday, or this morning, I guess. And then I'll move on to describing some of the problems that are due next week and how you can solve them. Okay. All right, so let's start with the written part of the practice final. The first problem is about converting a decimal number into binary and into base 3. All right. So let's first look at binary. So when you start from a decimal and convert it into another base, you will repeatedly divide it into powers of the base. Okay. You need to identify the largest power of the base 2 or base 3 that's inside your number, and then subtract it from your number, and then keep repeating that process. So what's the largest power of 2? Let's do the binary first. The largest power of 2 inside 92. It's 64, right? So powers of 2s are to the power 0, to the power 1, 2, 8, 16, 64. To the power 0, power 1, 2, 3, 4, 5. Okay. So the largest power of 2 inside 92 is 64. So we start from 92. Then we are taking care of 64. Okay. How many 64s do we have? Just one. So we'll also record the number of 64s we have in 92. Let's subtract. So the answer is 28. So we've taken care of 64, now we have to take care of 28. We'll just repeat the process. The largest power of 2 inside 28 is 16. I forgot a number here. 5, 6, this is 32. Okay. 64 to the power 6. So I don't have any 32s, that's 0. I have 116. Let's do the subtraction. You get 12. Okay. Do I have any 8s? Yes, I have just one 8. Let's keep a 1 there. And when I subtract, I get 4. Do I have a 4? Yes. I have 1 4. And I'm done. I don't have anything else to take to 5. So the rest are 0. So you've consumed your number. At that point, any remaining powers will be 0. And this will be your answer. You can go back to verify your answer. Multiply each of these numbers with their values. So 1 times 4 equals 4. 1 times 8 equals 8. 16, 64. Add them all up. And you should get the answer back. All right? Okay, so now let's do in base 3. Let's again write down the powers of 3. 0, 1, 2, 3, 4. 3 to the power 0 is 3. Sorry, 1. 3 to the power 1 is 3. 9, 27, 81. Okay. We start from 92 again. And then you try to identify the largest power of 3 inside 92. That's 81. Okay. And how many 81s do I have? Just one. I just have one 81. And then let's do the subtraction. 92 minus 81. You get 11. All right. Do I have any 27s? No. Do I have any 9s? Yes. I just have one 9. One 9. You do the subtraction, you have 2 left. Do I have any 3s? No. Do I have any 1s? Yes. How many of them? 2 of them. And you have 0 left. Okay? So you not only need to identify the largest power of 3, but you also need to know how many of them you have in your number. So the last one was 2. You have it twice. And then that gives you the answer 10101. Sorry, 10102 is the answer. All right. Any questions? Okay, so let's do power 16. The same number to the power 16. Again, let's write down powers of 16. 16 to the power 0 is 1. 16 to the power 1 is 16. 16 to the power 2 is 256. Okay. Look at our number 92. Do I have any 256s? No. Do I have any 16s? Yes. How many of them do I have? How many 16s do I have in 92? If you divide 92 by 16, what do you get? 5, right? So you have 5 times 16, you have 80. The remainder is going to be 12. And then the next power of 16 is 1. How many of them do you have? 12 of them. And the answer is, well, the remaining number is 0, so you're done. But in base 16, you have a special way of writing these numbers. You're not just going to say 512, okay? You need to encode 5, that's 5, and 12, you need to write it in as a letter. So after 9, 10 gets A, 11 gets B, 12 is denoted as C. So it's 5C. And you would usually write down 0x, 5C. The 0x just, it's a commonly used prefix to denote that the following number is a hexadecimal number. Okay? All right. And then for each of these, you should be able to go back to decimal. If you are given a number in binary, base 3 or base 16, you should be able to go back to a decimal number. It's easier to go into decimal number, you just multiply and add up. All right. The next question is about structures. So we are creating a structure with 3 different fields: an ice field, a cream field, and a cake field. And you need to look at these values that you are specifying when you are calling the structure. If a value is a cell array, then the value, you could either have the number of values in the cell array as the number of elements you are trying to create, okay? Or you can have a single value which will be distributed to all the elements you are creating. All right, so let's look at each of these values. You have a vector 3, 5. So however many elements this function call is creating, they will all have the value of their ice field to be 3, 5. Okay. Let's look at the next value. It's a cell array that contains 20 and 40. 20 and 40 will be separated, okay? The first element in your structure array will have the value 20, and the second element in your structure array will have the value 40. So you already know that you will be creating a structure array with 2 elements in it. The next value is another cell array, but in that cell array, you have a single element, which happens to be another cell array. Okay? So for all of the elements in the structure array that you are creating, they will all have the cake field equal 7090 cell array. So in a call to the struct function, you need to look at the values. If you encounter a cell array, then you need to look at the size of that cell array. The size of that cell array determines how many elements you are creating in your structure array. So the size of this one is a 1 by 2 cell array. The size of this value is a 1 by 1 cell array. Okay? So you have a cell array with a single element. Inside that single element, you have another cell array that contains 2 elements. Okay? But you're only concerned with the outermost layer. Okay, so let me show the values of all the fields for the 2 structure arrays, for the 2 structures. So I have, I'm just going to denote them like this. You have the ice field, cream field, and cake field. Ice, cream, cake. This is P1, that's the first element. This is P2, second element. Since this is not a cell array, all of the elements will get the same value, P5. The cell array, it gets distributed to your elements in the structure array. This is another cell array, but a single element in it. So that will be replicated in each element of your cell array. 70, 90, 70, 90. Okay. All right. So let's look at what we are trying to display. And again, we are creating a variable ice. That's a separate box called ice that has the value cream. It says string value cream. Let's try to figure out P sub 1 dot ice. So P sub 1 is the first element in your structure array, and you are getting the ice field. That's going to be 3 and 5. So this thing is going to be replaced with 3, 5. Next thing that I'm extracting is P sub 1 dot cream. The 20, so this will be replaced with 20. So far I have a vector that contains 3, 5, and 20. Next element is P sub 1 dot cake. So I'm referring to this entry here. And then I have curly bracket 1. So within that entry, I'm extracting the first element of that cell array, 70. So the value of that is going to be 70. And the last one is a little tricky. So I'm saying P sub 1. That's, again, the first element of the structure array. Whenever you see dot parenthesis, that means you need to evaluate the expression inside the parenthesis and use the evaluated expression's value as the field name. So this is not accessing the ice field, it's accessing the value contained in the ice variable. So dot parenthesis ice will first look in this variable right here. It will extract the cream. So this is same as saying P sub 1 dot cream, which will be replaced with 20. Okay. So you would get the same result, same answer if you replace this variable name with something else. Let's call it x, and correspondingly replace this variable with x. P sub 1 dot parenthesis x. We are extracting the contents of the variable x and using those contents as a field name. All right. And that inside the parentheses, you can have a variable name or you can have any complex expression. You can have anything else, such as a function call, that results in a string. Let me give you an example of that. So let's say I have a structure B equals struct B comma 5. Okay, so I have a single element in my structure array. It has a field B, which has a value 5. So you get something like that. Field B, value 5, and that's P or P sub 1 will give you the same structure. Now let's say we have a variable named x that contains the value A. I could say P dot parenthesis x plus 1. All right. So dot parenthesis again means you need to look at inside the parentheses and evaluate the expression. So first you need to identify what x plus 1 is. It's a plus 1, which evaluates to, so this is going to be the same thing as p dot b, which will be 5. Okay. On the other hand, if I set p dot x, that would assume there's a field of p named x, which there is not. So you would get an error if you try to say p dot x. So I hope you understand the distinction between dot a field name and dot parenthesis an expression. Clear enough? Okay, good. Next question is about cells. And here you need to know the difference between using parentheses and curly braces. When you use curly braces, you are extracting the contents in a cell array. When you are using parentheses, you are referring to elements of a cell array, but as a result, you still get a cell array. So you are not opening the package, you are just selecting blocks and creating a new cell array. We are given this cell matrix, M equals, let me just create a box figure. And I'm just going to double box it to show you that it's a cell array. Just to do this. I have 4 elements. It's a 2 by 2 cell array. The first element is 1, 5, a vector 1, 5 that contains the numbers 1 and 5. The second element is on the same row you have a cell array 1, 5, and then numbers 1 to 5. So that's a vector 1, 2, 3, 4, 5. And then the last one is a cell array 1, 2, 3, 4, 5. Double check something. I lost everything. Of course, I'll rewrite it. Let me just quickly redraw this. 1, 5, cell array 1, 5, numbers 1 through 5, a vector. And the last one is a cell array and then a vector 1, 2, 3, 4, 5. All right, so the sizes M parenthesis 1. You don't even need to look at what contents you are extracting. All right, so M is a cell array. You are referring to just one of its elements, M sub 1. So regardless of what those contents are, you should already know that you will result with, this expression will result in a cell array with a single element in it. Okay? So you are referring to this first box right here. but it's a double box. You're not destroying the outer packaging. You still get a cell array, and you don't really care what you have inside. It's a cell array with a single element. That's why you have one and one, a one by one matrix or a one by one cell array. The second expression is doing the same thing for m sub 2. Again, you are referring to a single element of the cell array. You don't even need to, again, you don't need to look at the contents. It's a single cell array with that 1,5 in it, but its size is 1 by 1. And the same logic applies to the other ones. M sub 3 is a 1 by 1 cell array. M sub 4 is a 1 by 1 cell array. So when you are using parentheses, the size of the resulting cell array is determined by how many elements you are indexing. If I said M parenthesis 1, 2, so this is linear indexing, right? I'm going to access them, I'm going to extract the first column. I will get a cell array that has 1, 5, and 1, 2, 3, 4, 5. But this expression gives me a cell array that is 2 rows and 1 column. Okay. So the size of the resulting cell array is determined by how many elements you are indexing. All right. Now, when you are using curly braces, you are opening up the box. Okay. So you are losing that outer package. I'm gonna have to rewrite that. So let's see. So I have 1, 5. 5, and curly braces 1, 2, 3. I'm extracting, I'm referring to the first box in that cell array, in that cell matrix, and then destroying the outer package. So what I will get is 1, 5. I'm getting a vector that has 1 row, 2 columns. That's why I have 1 and 2. Next expression is doing the same thing for the second box. But this, you have to, again, be careful that this second box is column indexing. So it's going to be this one right here. So you're going, this is the first box, second box, third one, and third one. All right, so again, you take that box and get rid of the outer layer packaging, the cell packaging, and as a result, you will get 1, 2, 3, 4, 5. It's a vector with 1 row, 5 columns. The size function will tell you its dimensions, 1 and 5. On the second row of the matrix I'm creating right here, after the semicolon, I'm getting the contents of the third box of M. That's that one right there, which is a cell array 1, 5. Okay, so it's a cell array, which is something like this. 1, 5. It's a 1 by 2 cell array. We get 1 and 2. The last one is, again, a cell array, but now you have a single element, 1, 2, 3, 4, 5. So inside that cell array, I have a vector. The size of the cell array is a 1 by 1 cell array. Okay? Make sense? Confusing? All right, so let me repeat this for m parenthesis 4. So m parenthesis 4 would look like this. Um, I'm just going to draw it on the same figure. So the red one is m parenthesis 4, and the blue one is m curly braces 4. And inside of that, you can further get that vector by saying m curly bracket 4, curly bracket 1. So each time you use a curly bracket, you are destroying one layer of packaging. So m curly bracket 4 is going to get rid of this red packaging, and then curly bracket 1 is going to get rid of this blue packaging, and you will be left with a regular vector. Okay? Any questions? I think I forgot to say talk here so people can. All right. So let me keep going. In the next problem, you are asked to take a cell array A that contains names of students. So it's a cell array with strings in it. And B is a numerical vector of student grade. So for each student, you have their name in the cell array A, and their grade is in the numerical vector B. So for example, A is in curly brackets, Ahmed, Ashley, Berk, Ori, Derek, and Emily. Okay, so it's a cell array where the first element is Ahmed, the second element is Ashley, um, Ori, Derek, and Emily. Okay. And the vector B is numerical vector that contains their grade 90, 100, 100, 85, 99.9, and 100. So I have more B's than names of students. I left out back. Just create something here. Back gets 100. This person gets 85, 99.9, and Emily gets 100. Okay. All right. So what we want to do is have a single statement that will assign into C the names of students whose grades are 100. So you need to identify the students that have a grade 100 and then access the cell array to get their name. So you need to index, you need to create a logical expression on this vector B to get ones that have a grade 100. If you just say B equals 100, you will get a logical vector that has a 0 for those students whose grades are not 100, and a 1 for those whose grades are 100. Okay? 0, 0. Once you create this logical vector, you can use it to refer to elements of A and get the names of those students by simply saying A parenthesis I. A parenthesis I will create a new cell array with the names of the elements that you have a 1 here. So you'll get Ashley, Beck, and Emily. It would be the same thing as saying A, vector notation, the second element, third element, 4, 5, and 6 element. All right, so let's put this all together. Since we are asked to write a single expression, you don't want to generate a new variable I. You want to do this in one step. So b equal 100 is going to give you a logical vector with having ones wherever the student's grade is 100. And you are using that to index A. You are using parentheses to index it, not curly braces, because you are generating a new cell array with names in them. And though you will get the names of students with grade 100. Okay? Yes, question. Can you repeat the question? So if you want to get the names of students that did not have 100, then all you need to do is find a logical vector that contains ones for those students that don't have 100. So that's one way of doing it is to replace that equal with not equal. Okay. Or you could also do b equal 100 and take the negation of that. Or you could, if you want to assume that your grades will be at most 100, you could also say A be smaller than 100. Any of those will work. The idea is to create a logical vector that will contain ones for the elements you are trying to index. And then use that logical vector to extract those elements and create a new cell array out of them. So I told you that you should not use curly braces. The reason is that if you use curly braces, you would get individual strings out, but you are trying to get a collection of strings. One, sometimes you may want to get the contents, and that usually involves having your index being a single element, or a logical vector that contains a single string. And I'll give an example of that when I'm describing next week's homework. Okay? So in next week's homework, what you have is, let's say you are guaranteed that student names are unique. Then we don't have any two students with the same name. And you want to identify, well, let's go the other way. Let's say you have only one student having the grade 85, and you want their name, not as a salary, but their actual name. You don't want a collection of names, you want a single name. All right, so what you would do is say b equal 85, and use curly braces to get from A. So what this will do is it will give you a single string that has 40 in it. A parenthesis d equals 85 is going to give you, again, 40 but in a cell array. Okay? All right. Any other questions? I'm going to move on to the next problem. Okay. So in the next problem, we have a cell array of names, cell array of strings that contain the names of the variables, and we have a data matrix. So this is very similar to an Excel sheet that you would have, where the first row is the header field. It contains the names of the fields. It represents what each column contains. And then each row contains an item, a data item, with those column values. So our data matrix contains 1, 2, 3, 4, 5, 6 rows and 3 columns. And each of these columns corresponds to one of these variable names. So the first person is in group 1, has a height 60 and has a weight 130. The second person is in group 1 again, height equals 70, weight equals 160, and so on. So you can create a matrix of this if it helps you. I need more rows. 1, 2, 3. So I have group ID, height, and weight. In group 1, 60, 130, group 1, group 2, group 1, 3, and 2. 60, 70, 64, 68, 65, 6, 160, 140, 180, 150. Okay. So in the first expression, let's look at the innermost expression first. So we are applying str compare function. We are giving it a cell array of strings, those variable names. And the second argument is the string height. So str compare means compare strings. So the arguments could be 2 strings. So your first argument can be a string and the second argument a string. Then it will tell you whether they are equal. If you give as the first argument a cell array of strings, then you will get a result that compares the second argument with each of the elements in the cell array. And you will get a vector of trues and falses. Wherever there's an exact match, you will get a 1. And for those strings in the cell array that do not exactly match the second argument, you will get a false. So for this example, where vars is the cell array, you are comparing with height, so you get 0, 1, 0. That's the result of the str compare function. So you get a logical vector, okay? And then I'm using that logical vector to index the data matrix. Let's look at the next level. So start from the innermost expression, then expand out. You're looking at the data matrix, okay? I'm getting all rows, so the colon, and then comma, that expression which is a logical vector. So you're accessing all rows and second column. So the logical vector it's a map that you place on each row. So essentially you're extracting the second column of this data matrix. Make sense? Okay. And I'm displaying the results. So it's 60, 70, 64, 68, 65, and 66. So it's all the elements in the second column of the data matrix. Let's look at the next expression, next problem. Again, let's look at the innermost expressions first. I am looking at the data matrix, getting all rows and the first column. So I'm extracting the first column of the data matrix, which will get me this button. Let me take it out and write it somewhere else. 1, 1, let me write under it. This will give me 1, 1, 2, 1, 3, 2. Okay. Let me look at this part. I'm doing the same thing, comparing variables with the string height, which will give me this logical vector. 0, 1, 0. Okay, so I skipped this part that compares with equal, equal 1. So of the first column that I extracted, now I'm comparing those values with the value 1. As a result, I will get a logical vector that contains 1 whenever in that first column I have 1 and 0 everywhere else. Okay, so this will be 1, 1, 0, 1, 0, 0. So you have a logical map for rows and a logical map for the column. Essentially, I'm referring to the first row, second row, and the fourth row, and the second column. All right. So I'm indexing data, and then in that indexing, the rows that I'm referring to are the first row, second row, and the fourth row. First row, second row, and the fourth row. And the column that I'm indexing is the second column. Okay. So I'm referring to those rows that have the group ID equals 1. I'm referring to their second column, the height column. Is the question?
Yeah. For all three of these like commands, there's an extra quotation mark on the very end. Where's the quotation mark that's
There's an extra quotation mark. Okay, let me get to that in a second. Okay. All right. So let's extract the first row, second row, and the fourth row, and the second column. The answer that you will get is 60, 70, and 68. So you get 60, 70, and 68. That's the resulting vector you are generating. And if you display this, you will get a column display, all right? And to show it on a single line, I'm taking the transpose, so that way it shows up as 60, 70, 68. Okay. So I'm taking the transpose essentially so everything looks, you can write everything on a single line instead of using up more paper space. Okay. All right. Things are getting crowded, but I think I'll be able to. Oh, okay. I'll just go use this data matrix. Or let me do this. Let me copy and paste this into MATLAB here. And then take this. It did not work. Okay, this is good enough. All right. This is my matrix data. And this is the group, height, and weight. Again, we're going to look at the innermost expressions first. We are comparing variables with group. str compare vars comma group is going to give you a logical vector. You are comparing this cell array of strings with group. As a result, you will get 1, 0, 0. Okay. So the first element in your cell array is group. It's an exact match. The second is height. It doesn't match with the group. And the third element is weight. It's not the same as group. So you get a 0. 1, 0, 0. Okay? So that part is good. In the next part, you are indexing data with all rows and essentially the first column. So you're extracting the first column of your data matrix, which will give you these numbers. And again, you are comparing it with 1, which will give you a logical vector. So this part is 1, 1, 1, 2, 1, 3, 2. And as soon as you compare it with 1, you'll get 1, 1, 0. Sorry, this is 2. And then 1, 0, 0. So the same as before, the first, second, and fourth row. Okay. So you get a 1 wherever the group ID is 1, and 0 everywhere else. So this part, so far, we have a logical vector that contains 1, 1, 0, 1, 0, 0. In the second part here, you are comparing bars with height. So that will give you a logical vector 0, 0, 1. So you have this group height, 0, 1, 0. Or height, you get a 1. For the other two, you have 0. Okay? All right. So again, we have a map for rows and a map for columns. So you get 60, 70, and 68. Did I miss that problem? This looks like the same problem I solved. Nope. So you do get the same answer. So the difference between the previous problem and this one is the following. Here you have a 1, right? In this problem, I replace that 1 with this expression right here. And that expression is 1, 0, 0. The logical vector that tells you to get the first column of your data matrix. Whereas in the second problem, you extract the first column manually. All right, so that you are referring to the same data elements. That's why the answers are the same. Okay. Any questions? All right. So now let me move on to the programming problem. Matrix. So this function takes a matrix and a path. And we'll get a total score. Call that total. So I will initialize my total to be the first element of the matrix. Okay? And then I will also have a variable that keeps track of my current location. That's row and column in the C. Okay? For each element in the path, and there are two ways of doing this. One is to say I equals 1 to number of elements in path, and then examine path I, path I, And the other way to write this for loop is to directly extract the contents of path. So move equals path. So path is a vector. You are trying to uh, investigate each element of path. All right. You could either say I equals 1 to number of elements in the path, and then path parenthesis I is going to give you the ith element inside the path. Or you can use the values of path directly and have this variable move enumerate over them. Okay? Make sense? So you can do it either way. This one is equivalent to saying I equals 1 to null path move equals path sub I. All right. So once you get the ith move, what we'll do is we'll check if it is 1. 1 means going to the right. So if we are going down, we are going to increment RC 1 by 1. No, RC2. So this is the row number I'm in, and the second element is the column number I'm in. Let me make this bigger for you. You guys are not complaining about the screen. It looks dark on my screen. Okay. All right. So RC is the index row and column indices that I'm currently at. Move equals 1 means I'm moving to the right. That means I'm incrementing the column index. Okay, so RC2, I'm incrementing it by 1. All right. Else if move equals 2, I'm going to move down. That means I need to increment the row index of RC. Else, it's going to be a diagonal move. RC1 equals RC1 plus 1, and RC2 is also equal to RC2 plus 1. So you are moving in both right and down. You can do this in one step by saying RC equals RC plus 1. Okay? All right? So once I move, I need to look at the score contained in that new location and add it to my total score. Total equals, I need to index the matrix, the input matrix. That's my row index, and this is my column index. This would replace the current value of total. I need to add it to the value of total. So I'm accumulating score that I see. Okay. And at the end, this will solve the problem. Let's check it for the given example. And you get the correct answer. Okay. All right. So let's try to make this solution shorter. You have different summations depending on your move, right? What we could do is encode these different summations in a vector or in a matrix. Okay. Let's call this move. So I'm defining my move. When move equals 1, I'm going to have increment the column by 1. When move equals 2, I'm going to increment the row by 1. When move equals 3, I'm going to increment both of them. Okay. So now this moves matrix, each of its rows contains the amount by which I need to increment my index. Okay. So doing that, what you would have is, as soon as you get a move, let me shorten this by saying move equals path, meaning move takes individual elements that is passed in the vector path. And the reason I don't want to use the variable name path is because it has a special meaning in MATLAB. And that's why you get path instead of path. All right. So move will contain 1, 2, or 3 at any given time inside this for loop. And depending on its value, I can index this move matrix and get the increment value that I need to increment my RC index. Okay? So the new value of RC is going to be RC plus move, move, all. Okay? Make sense? All right. So when, let's say, move equals 1, then you are accessing the first row of move. That's going to be 0, 1. And you're adding 0, 1 to your index, which means you are incrementing the second element in RC. You are increasing the column number by 1. Okay? All good? So this also solve the problem in the same way. Copy and paste the example here, and you get 17 again. You can make this, you can solve this in a different way. Instead of row and column indices, you can use linear indexing, and let's say index equals 1. If you want to use linear indexing, then you need to update these increments accordingly. So, move to the right means you need to add the number of rows in your matrix. So let's say RC equals size of matrix. For a move to the right, you need to add R. For a move down, you are just adding 1 because it's linear indexing. By moving down would mean that you are adding just 1 to your linear indexing. Moving diagonal means you need to add R plus 1. So these are the values by which you need to increment your index for each type of move. When the type of move is 1, you are moving to the right, you are incrementing your index by R. So now our change this index equals index plus move. Okay. And now I'm using linear indexing. Don't have a comma, it's just a single index. Let's test this again, and you get a 17 again. Okay. So different ways to solve the same problem. Any questions? So instead of adding this one by one, what some of you have also done is to create a vector of elements that you are traversing in this matrix. E and D plus 1 equals matrix IDX. Initially, it needs to contain matrix 1 by 1. And then at the end, the total is going to be the sum of those values. This will also give the same answer. Okay. All right, any questions? before I move on to the next problem? No. All right. So the next problem is get site. It's file input output. We are given this small file. Let me just open it again. I save it into the current folder. Function get site. We take a rebase file and I don't know if the rebase file is optional, but you could just say if not exists rebase file variable, then rebase file equals rebase small.txt. Let me also give a default argument for enzyme, so I don't have to type in the command window all the time. If not exists the enzyme variable. So this is just to speed up debugging and running the code. And enzyme equals, what's an example here? Use this example. So those are my default values. What I need to do is open the file first. So fid equals fopen rebase file. I'm going to read from the file. If you want to do error checking, you could say if fid is equal to -1, then error failed to open file. Okay. And the reason I know that this is the case when an error happens is by looking at the documentation for fopen. So if you look at the documentation for fopen, you will see that when there's an error, what does it return? So if fopen cannot open the file, it returns -1. Okay. So by checking whether the result, by checking when the result of fopen is -1, you can print out an error and stop your execution there. All right, so we have our file open at this point. Anytime you say get line, you will be reading the next line from the file. So one way of solving this is just saying while true. While true, let's read the next line. This will try to read the file infinitely. I need to detect when I have consumed the entire file. And that can be done by checking the return value of fgetLine. When the fgetLine successfully reads something, you'll get the string that has the value of that line. If it fails, you get a -1. So you get something that's not a character array. When you consume the file and you're at the end of the file, you'll fail to read the next line because there's no next line left in the file. So what I could do is say if not is character line, then fgetLine function has failed. I can just break out of my while loop. Okay. All right. Now what I'll do is check whether the first part of the line contains what I'm looking for. So here, let's say, where's my MI? So for each line that I'm reading, I need to test whether it matches this string right here. that can be done by saying if str compare line, then there's going to be a concatenation of, of two different strings. I'm constructing this string that I'm expecting to find. The first part is constant. It's more than one greater than string. And the second part is variable. It depends on whatever I pass to the function. All right. So as I go through this file line by line, I'm going to detect this line. Okay, whenever I read that line, I'm going to detect it by saying if str compare line with that. And when I detect that I'm currently on that line, I'm going to keep reading further and then get this recognition sign. So the rest of this process is identical to this, right? You still need to keep reading line by line, and then you need to check whether you've reached a certain prefix. All right, so while true, you get the next line. If it fails, you break. But now I'm going to look for something different. Now I know the first part, which is smaller than 5 greater symbol, but I don't know the next part. The next part is what I'm trying to extract and return. All right. So I shouldn't be using, I should not be using the str compare function. Instead, there's another function called str and compare, which will compare only the first 3 characters. Can equivalently say check the first 3 characters and see if it's equal to that expression. Okay. But this has a caveat. Whenever you are trying to access the first 3 characters, there is a possibility that that line does not contain enough characters. Okay, and that's why str and compare is safer to use. It will take care of that possibility for you. So if line contains less than 3 characters, it will still work. Another way of doing this is to say str compare line 1, 3, and number of elements in line is greater than 3. Okay, so first you make sure that you have at least 3 characters, and then you check that the first 3 characters contain the expression you are looking for. So once you find this line, so we found this, that we have this enzyme name. We kept reading line by line, and all of these are going to fail this if test. This one is going to succeed in the if test, and then it's going to move into the if statement. Now, the part past the greater than symbol is going to be what you want to return. So the site equals line 4 to the end, and let's close the file and return. And let's also close the file here. One way is to break here, is to just say break, and then the site will contain the value you are looking for. But since you already know that you shouldn't really be processing the rest of the file, you already have your answer, you can return immediately, but before returning, make sure to close the file. All right, so let's test this function. It gets the correct answer. Let's test this one. Gets the correct answer. Test this one. And you get the correct answer. Okay. Any questions? All right, so let's take a very short break. I'll show you a different way to solve this problem, and then try next week. All right, so let's now solve this problem using regular expression. Okay, or before I start with regular expression, let's solve this problem by first reading the entire file. So I open the file, then I'll do fread, fid. Let's do that. S equals. Let me do this in the command window first. I'm opening the file, and then fread. This will give you the binary representation of the character. Okay, so you get all those numbers. Let me open it again. I can convert those binary numbers into characters. Now you get that. You get a one large column vector. That's why I need to take the transpose. Let me open the file again, and you get the contents of the file in a single string that's a row vector. Okay? The fact that in the command window you see them on different lines can be misleading. Internally, this is one large row vector with some of the characters being new lines. Okay? So let me open the file again and then save this vector into S. And if you look at the size of S, it's a 1 by 4,000 character array. Okay. All right. So now the variable S contains the entire contents of the file. What you could do is use strFind function to locate what you are searching. So I'm no longer looking at the file line by line, but now I have the entire file in a single variable. I can locate what I'm looking for using the strFind function. I have one large string, I'm searching for one smaller string. And the small string that I'm searching is this one right here. So this will tell me the location, if present, if that smaller string is a large string. Enzyme is not defined. Let's evaluate this. So I have the enzyme variable available in the command window as an example. Now strFind, that tells me that at the 551st position of the variable S, I have the enzyme name. Let's examine that location. 551. You have the small decimal. Let's examine a few values past that. You have that. Okay. All right. So you've identified the starting position of your enzyme information. Next, from that point onward, you want to look for smaller than 5 and then greater than. Okay. What you want to do is first save the location of this enzyme, and then from that point onward, we're going to do another strFind, but now search for 5. Oh, there's going to be a lot of them because you are not only finding the restriction site for that enzyme, but also all the following enzymes. So if you look at the file right here, the position is going to give you this entry right here. It's going to be the 551st character of your string. And then from that point onward, you do another strFind, now searching for this smaller than 5 greater than string. But you have a lot of matches, right? You have all these matches in your string. You're only interested in the first one. So let's do this again. Let me save this in another variable called post5. Equal that. So That's going to be all the matches, but I just need the first one. It's 54 characters. But that 54 is the 54th character of this new string that I've extracted. The actual position in my original string is going to be this pose plus pose 5 sub 1. So let me just do this, pose 5 equals pose 5 sub 1. And then position plus pose 5, that's going to be 605. So 551 was here, and then 605 should get me right here. Let's test S 605. There's going to be some plus minus ones that you need to take care of, and we'll do that now. So let's take a look at a few characters following that location. So it's not just this, actually you need to move back by one at the 104th location. Okay? All right? Okay. So let me go back and select the things that I did into the file. I found the location of the enzyme information starting point, save that in a variable called pause, and then I found the locations of all the fives in the entire string following this pause. And then this expression right here gives me the absolute position of the restriction site for that enzyme. Okay. All right. So this expression right here is going to be this string data all the way to the end. What I will do next is starting from here and then look for a new line character. Okay. And you will find a lot of new line characters, one here, one here, one here, one there. Okay. Let's use the first one. Equal new line, which is number 10. Or you could also do sprintf new line. Let's say pose new line. And then we will only use the first one. Let me evaluate this. Look at the contents of pose new lines. Can be a lot of strings. Sorry, a lot of zeros and ones. And then if you do fine, you get their absolute position. It's convenient to do this and update your string S so it contains only the last part. So you're getting rid of the first part. That way you don't need to worry about things like adding the prefix, the offset. And now I can test the locations that are equal to new line. And then I will use the first one. Starting from the first position of S all the way to the first new line is going to give me that entire line I'm looking for. So let's evaluate this. I forgot to define. All right, so let me start over because my variables do not contain the things that I expect. And we'll clean up and then we'll type again. So I'm opening the file, I read the entire file. Since I already have the entire file in a string, I can already close the file. I'm going to find the location of that one followed by the enzyme name. That's going to give me the position. Now I'm going to change it slightly. I'm going to update my string so I get rid of all the part of the string that's off that point. 1 all the way to pose -1. Okay. So let me copy and paste this and show you the results. Go to selection. You find the position, and then you update your S so that you are removing the first part. So it just needs to be paused all the way to the end. Evaluate selection. So now S, let me just look at the first 100 characters. It's going to contain, starting from that enzyme all the way to the end of the file. All right. But now I can directly search for this 5. And I'm just going to reuse the position variable. I no longer need this because the string S already contains the last part. And then I'm going to do one to close. Sorry. What I need to do is, again, remove this portion right here. Okay, I'm going to remove that portion, so the string S will now contain that portion. Okay, let me evaluate that. So I do that, and then show you the first 100 characters of S. So you are at the beginning of that line that contains 5. Next, I'm going to find new line characters. Printf new line. But now there's going to be a lot of them. You only need the first one. And instead of removing up to the new line, what you want to do is remove past the new line. Right now, I'm trying to remove the last portion of the string. That's why I keep only one all the way to the position. Okay, so let me run this. Now S contains that string. You only need the first 3 characters. You can get rid of them by saying S equals S or all the way to the end. And there will also be a new line character at the end which you don't need, and you can use the trim function to get rid of that. So to remove the non-visible new line characters at the end. And the site is going to be that. Let's test this, get site, and hopefully it will work. Looks like trim is not a function that I was looking for. There's a function called strtrim that I should be using. Okay, so I got the answer. Get site. Start with this example. And it works again. Okay? Any questions? All right. Excuse me 1 second, and then I'll finish this off.